So good morning all. We will start today with the Python OOPS concepts. So we would be understanding what is OOPS. So OOPS is nothing but it's an object-oriented programming language. Okay, or Python object-oriented programming. So what does it mean? Python object-oriented programming and why it is important? In every industry, whenever you are going for good companies or good organization, each and every industry is following these concepts. Okay, so basically oops concept are usable. So it is a multi paradigm programming language. Okay, and it supports different programming approaches. Okay. And another thing about the oops is that, okay, if we want to focus on creating a reusable code, okay, if we are writing some reusable code, so instead of writing functions and other things or repeating those lines of code, you can use oops concept. Okay, it helps us in organizing the reusable codes. Okay. So we will study about the two things. We'll study about the objects in OOPS, what are objects in OOPS. Okay, and another thing is classes. So what is object? So object is nothing but it is the smallest entity which contains some attribute. It has some attribute and behavior. Okay. So if I take an example, let us take an example. So let us take a real life example. If I talk about a parrot, so a parrot is known as object. Okay. And what are its behavior? It could have its name, it could have a age, the color of the parrot. So these are the attributes. These are the attributes of the parrot. What are its behavior? So let's say a parrot can sing. So singing can be its behavior. Dancing could be its behavior. Okay, our behavior. So a object is an entity which is associated with the attribute, which has its attribute and a behavior. Okay. So let us discuss in detail about the class first. So what is class? So class is nothing. It is the blueprint. It is the blueprint. Okay. We are just going through. It is the blueprint of the object. We would be just going through the few theoretical aspects, and then we would be covering the practical things. Okay. But at this point in time, you need to understand that a class is a blueprint of the object. An object is nothing but it is associated with a attribute and behavior. Okay. Here we took an example of parrot. Parrot is known as object and it has its name, age, color as the attributes, and singing, dancing as a behavior. So let's say if I want to create a class, if I want to create a class in Python, then we have a keyword class. Okay, the moment I write a keyword, it would turn into green, and that's where you can create a class. So let's say I'm creating a class parrot. Okay, and just creating the empty class. So this is an empty class. This is an empty class. Okay, we have just created this class. Okay. Now there are few things inside the class. So first is there is a self keyword. Okay, there is a self keyword, and this represents the instance of the class. Instance of the class. Instance means object. Instance is nothing but an object of the class. Okay. Through self keyword, through self keyword, we can access the attributes attributes and methods in the class. Attributes we already learned here. These are the attributes. Name, age, color could be attributes. Methods are nothing but functions. So whenever we are talking about the class concepts, we do not talk about functions. We call them as methods. We call those things as methods. Okay. So let us see a class. Let me try to create a class and let me try to give you an overview about that class. So let us create a class person. So here I have created a class person followed by colon. Okay. And let me give the comments to this class. So I'm just telling that, okay, this is a person class. Okay. This is a document that I have attached to the class. Inside this, I am creating one variable. Let's say age equals to 10. Okay. So this is a variable. This is a variable. Okay. But inside class, we'll call it as attribute. This is a attribute. Okay. Then let us create a method. How to create a method? Define inside that class greet, and each function inside this class is associated with a self object. So it is mandatory to write this self. Okay, with this you can access the function. So we'll study when we'll go further in depth about this concept. You will come to know that, okay, what is the actual use of self. But if I want to define a function outside the class, so I'll write def greet, and I will not write the self keyword. But whenever we are inside a class, each and every method is associated with a self keyword. Okay, and let us write print hello. Let us print hello here. Okay, so this is the class, and here this is the attribute of the class, and here we have created a simple method of that class. Okay, so let me run this. So see, a basic class is being created. Basic class is being created. Okay, and what I told you about the class is the blueprint of the object. Class is a blueprint of the object. Now let us try to access the age. Access the age outside the class. If I want to access the age, so that's where I will write a class name, and I will write class name dot age. So see, I'm getting 10. Okay. If I want to access this attribute outside the class, that's where I can add person dot age. Okay. Let us try to access the function or the method. Access the function or method outside the class. Outside the class. So I can add person dot greet. Let us see whether am I getting this output or not. So the moment I write person dot greet, so you would see that it is trying to tell that, okay, it is a function. It is a function and it is expecting some parameters. Okay, there is a self object associated with this. Okay, so it will just let us know that, okay, person dot greet is nothing but it's a function. Person dot greet is nothing but a function. Okay, let us say I want to access the document. Access the doc of class. So that's where I can do person dot underscore underscore doc underscore underscore. So you would see that this is a person class, the documentation or a doc string that we have written for the class, that is also accessible here. Okay. Now let's say I want to call this function. Can I call this function outside the class? Okay. Calling the function or the method outside the class. So at this point in time, let us do a very simple approach. Let us pass a person. So see, instead of self, this is a parameter, right? So instead of self, I'm just passing a class name. At this point in time, I'm just passing the class name. So I'm writing class name dot function, and this function is taking the parameter as self. So self means an instance of an object, instance of a class. Self is an instance of a class. So we have not created the instance, means we have not created the object. So that's where we can pass the class name at this point in time. Okay. As and when we proceed, I'll tell you, we will just extend this concept, and then we would be accessing these functions or the methods with the help of objects. Okay. Now let us understand what is object. If this is a class, then what is object? Okay. So a object is a instance of a class, instance of a class. Okay, using object we can access the attributes and the methods. Okay, this could be a behavior. Okay, this could be behavior and these are the attributes. Using object I can access the attribute and the behavior of the class. Okay, getting? Whenever we getting? Yes, no? Okay, let us try to uh, create a object, create a object of class person. So let us say I have created a object, variable name is obj or object name is obj. And how to define a object? So I'll write class name. I will define a class name followed by a function sign. Class name followed by function sign. Okay, so it is an object of class, a person, class person. Okay, if I want to create an object of class parrot, so let's say I can give obj1, okay, equals to, what is the class name? Class name is parrot, and defining the function sign. Okay, so see, it is running. Can I check the type of object? So see, it is telling that uh, I am belonging to the person class. If I check type of object 1, this object belongs to the parrot class. This object belongs to the parrot class. Okay, now if I write obj dot and press tab, so you would see I am able to access age and greet. See, now this object of the person class contains two values. Okay, one is attribute and another is method. So if I write object dot age, so you can see that directly I can access the age of the person. If I write obj dot greet and call the function, so you would see that now I am directly getting that output as hello. See, earlier we have not defined the object here. That's why we are passing inside this a class name. That's why we are passing the class name, because we are trying to call this method without the object. But once I create this object, internally Python will call these things. It will write person dot greet of person. So behind the scene, it is doing these things. Okay. Yes. No. Okay. Let us create another class. Let us try to extend the class parrot. Okay. So I'll create a class parrot. Okay, and then I'm defining the class attribute. So species, what are the species that parrot belongs to? It belongs to the bird species. Okay, then instance attribute. So now I'm defining one function, def underscore underscore init underscore underscore. These are the special functions. These are the special function, and underscore underscore init underscore underscore is constructor. It is constructor. Okay, so we'll talk about this constructor. Give me 10 minutes. After that we'll talk about the constructor. Okay. Hold on. You just want to print underscore underscore. Okay. So this is a special method which is known as constructor. Okay. Inside this, first parameter is always self, and what are the parameters that it is expecting? I am expecting name and age to be given. Name and age to be given. Now we want what we want to do. We want to initialize this. So here I'll write, okay, self dot name is equals to name and self dot age is equals to age. The name passed by the person, okay, the candidate who is invoking this class, okay, he has to pass the name, and that name we are assigning to the class attribute. Okay, the age we are assigning to the class attribute. Okay, now what I'll do is let us run this. That's it. So this is nothing but a constructor. Let me write here constructor. It is nothing but a constructor. Now let us instantiate the class. Instantiate the class. That means calling the object. Create the object. Create the object. Okay. Now when I invoke this class, here is a constructor. So basically this class is expecting two parameters. This class is expecting two parameters. Okay. This class is expecting two parameters. Why? Because constructor is being invoked. Constructor, this function is called the moment I create a class. The moment I create a object of this class, the constructor is invoked. I need not to call that constructor explicitly. What do I mean by that? So let's say here I have created a class and I have created this method. Okay, I am explicitly calling that method. So you would see here I am writing object.greet, and then that method is being invoked and it is returning the output. But in case of constructor, the moment I create an object, this function would be called automatically. This function would be called automatically. Okay, let us let me write a print. Let us write the constructor is invoked. Okay, and let us remove this. At this point in time, let us remove both these things and let us see whether the constructor is invoked or not. Let us try to create an object of the parrot class. Parrot. Okay, so see, automatically it is called this constructor. That's where, see, I am not calling this method. The moment I create an object, this method is invoked automatically. I am not going to explicitly call this. So this is a constructor. This is a constructor. Okay. Now if I remove this and I want to pass two parameters to this class, that's where I have defined this inside the constructor, and I'm writing name and age, and I'm assigning to the self. Okay. Now when I'll invoke this without the parameters, so that's where you would see, let us run this. So you would see an error. Okay, why? Because it is telling that in it is trying to call the constructor, and this constructor is expecting two parameters. This constructor is expecting two parameters. So it is telling that, boss, these two positional arguments are missing. So that's where whenever I want to invoke a class, so I have to give a name and age as a parameter. So let us give name as blue, PLU, and let's say age of the parrot is 10. So see, now it is running. Now it is running. Okay. Now let us access the attributes. Access the class attributes outside the class. Okay. Access the class attributes. So how can we access? So that's where I can write, okay, this is my first object. I can also create another object. So let us create one object as blue, another object as woo. Again I can call parrot. So this is a parrot. whose name is Wu and whose age is 15. Okay, so that's where you would see I have two objects. So I am reusing this class. I am reusing this class. So first parrot color is blue. Okay, name is blue and age is 10. Another parrot name is Wu and age is 15. Okay, so I have two different objects created. Let us now access the class attributes. Print. Okay, blue is a format, or we can write it inside. Let me write a formatted string. Okay, blue is the object. Okay, how to access the class attribute? Let me just tell you, blue dot underscore underscore class 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 underscore underscore dot, and this is the attribute that I want to access. So that's where you would see that, okay, this is a bird. The species is a bird type. Okay, so blue is a bird. Okay, and again I can create, print another statement, Wu. So that's where you would see now I will access it via Wu. Wu dot class species. So see, blue is a bird and Wu is also a bird. Okay. Now let us try to see the name and age. Are we able to see the name and age of blue and Wu? Let us try to see the name. So let us access the instance attributes. So please understand, this is a class attribute. Anything with the attributes which are defined just after the class, the attributes which are defined just after the class are known as the class attributes, and the attributes which are defined within the self, okay, those are the instance attributes. Instance attributes. So access the instance attributes. So let us access print formatted string. Okay, let us access blue dot name, because name is an attribute. Okay, so I want to access the name of this object. Okay, is and age, blue dot age years old. So I want to tell that, okay, which parrot is what, how many years old. Then I have created another object Wu and another object here Wu dot age. So that's where you would see blue is 10 years old and Wu is 15 years old. Okay, if I write here also, if I show you blue dot age, that's where see it has the parameter 10. Okay, why it is containing that? Why it is containing that? We have just created the we have just called this class. We have just called this class, but due to this constructor method, due to this constructor method, we are able to access the name and age. Okay, due to this constructor method, we are able to access the name and age. Okay, so if here I am writing blue dot name, that's where you would see that the name is blue. If I change it to Wu, so you would see that we have passed name as Wu, and let us see the age. So age is 15. Okay, so this is the concept of class. We are trying to reuse this class, and we have created different objects. We have created different objects, and we are trying to use this class. So we learned about how to define the class, how to define the what are class attributes, what is the object of a class, and what are the constructors. What are the constructors? Okay. So constructors are always given by init method. Okay, and whenever you create the object of a class, the constructors are invoked. Whenever you create the object of a class, the constructors are invoked. Okay, let us try to create one more class. Example 2. Let us try to create another class where we would be calculating the complex numbers. So if I write class as complex numbers number. Okay, so what are complex number, which is a real part and imaginary part, right? I plus j. J is the imaginary part. Okay. So j is the imaginary part. So complex numbers are nothing. Complex numbers are nothing which has real part plus imaginary part. Real plus imaginary part. Okay. Now here I am creating a class which is a complex numbers, and here first I'll define a constructor. Let us define the constructor. So how to define the constructor of a class? I'll let def underscore underscore init underscore underscore. Okay. Now I know the first parameter would be self. Okay. Self is the, through this I will try to access the instance attributes. Then I know that complex number, in this complex number it has two parts. One is real and another is imaginary. So that's where I have initialized those with 0. I have initialized those with 0, and here I can write self dot, I'm creating a instance and initializing with r, self dot image initializing with I. Okay. So whatever user will pass, it will be stored in real and image. It would be stored in real and image. Okay. Now I am creating another function. Now let's say method. In this method, I will just get the data. Get data. Self. That only self. Okay. And here I will write print. Let us just print that data. Self dot real. Self dot real. Self dot imaginary part. So this function is returning only this thing. So this is a very simple example. Okay, we have just created the constructor and we have created the method. Now you might be wondering that why we have not passed, why we have not passed the parameter here, a real and image. Okay, the moment I define a variable or a attribute, so see, inside the class, we do not call them as a variable. The terminology changes to attribute. So if you want to access the attribute from one function to another function or one method to another method, that's where you need to make that attribute as a attached with the self object. Okay. So let's say if I have one more parameter, let's say inside one more function. Okay, I'll tell that thing also, that when a method can be used, when a attribute can be used inside the another function and when it cannot be used. So let us first see the output of this. Okay. So let me call that as a num1 and complex numbers. And in that I need to pass 2, 3. So, okay. Now if I call num1 dot, so see get data. If you want to see image, so see inside image we have 3, imaginary part is 3, and let us see the real part. Real part is 2. Okay. Real part is 2. Now if I invoke that method num1 dot get underscore data, that's it. So you would see I'm getting the complex number 2 plus 3j. The output is returning as 2 plus 3j. Okay. We haven't passed anything. We haven't passed the real and imaginary. It's just we are using this self dot real here. Okay. Let's say now I want to add two numbers, add two complex numbers. So can we add that? Can we add that? Okay. Or let's say I have defined uh, add complex number. Okay. Here I have defined self and I want to self dot real is equals to self dot real plus a number which is being given by user. So that's where you would see that now I am not writing this number as self dot number. Okay, whenever I'm not writing this self dot number, so I need to define a number here, a parameter that we are expecting from the user. Okay, and now we'll print this. We will print this. Okay, now if I invoke this object complex number and let us do 4 comma 3. So now you would see num2 dot. So see, I am not getting a number as a parameter here. Okay, see num2 dot number doesn't exist, whereas num2 dot real and image is existing. So that's where these values we can access outside the class also. The moment I attach any attribute with self, we can access outside the class also, and we can access it within different functions, okay. This number parameter I cannot use in get underscore data, but whereas this self dot real or self dot image I can use in this get data attribute also, in add complex number attribute also. Okay, so this number parameter, okay, it the life of this is within this function. Okay, you cannot access this outside the function. You cannot access this number outside the function. Now let us add a complex number and let us pass a parameter as 2 and let us see the output. So see, I'm getting output as 6 plus 3j. 4 plus 2 is 6, 6 plus 3j. Getting this? So this is a concept about the complex number, and this complex number is expecting the two parameters, right? How about if I do not define, I have just directly invoked this complex number. So you would see now I'm not getting any error. I'm not getting any error. Why? Because when I invoke this constructor, when this constructor was invoked, it has directly initialized. By default, it is initialized with 0. By default, it is initialized with 0. When I'll show you num3.real, so you would see the value is 0, num3.image, the value is 0. Okay, I could also call this class with any one parameter. So let's say I only want to pass r equals to, let's say, 4. So you would see that the imaginary part is 0. You would see that the imaginary part is 0, but the real part has the value. Okay, I can also invoke this using only the imaginary part. So let us give imaginary to 2. Okay, so you would see that now the num3.image has 2, and whereas num3.real, the real part is 0. Okay, because we have initialized all these values and the constructor is taking care of these initializations. Okay, this is a concept of the classes, that okay, this is a class, this is a constructor, this is a method. Okay, if you want to access some attributes, then you want to attach that attribute with the self object. Okay, self is an instance of a class, and that's where this self dot real can be accessed in different functions. But if you want to access this number, since it is not attached to self, okay, it is not attached to the instance of a class, so that's where you cannot access this outside the function. The life of this parameter is within the function. Okay, so this is the difference between self.real or self.some attribute and the single attributes. Okay, now we'll talk more about how to delete the attributes and objects. Let us talk about deleting the attribute. Deleting the attributes and objects. So how to delete the attributes? So let's say I have created a complex number. I created an object. So let's say 2 comma 3. Okay. Now if I show you num1 dot real, num1 dot real, comma num1 dot imaginary part. So you would see that the real part has value as 2 and the imaginary part has value as 3. Now I want to delete the attribute. Delete the attribute. So let us delete the imaginary part. I want to delete the imaginary part. delete num1.image. Now if I again go and print this, let us print num1.image, and you would see it will tell that that attribute doesn't exist. Okay, this complex number class object has no attribute image. Okay, because we have deleted that attribute. Okay, if I do num1.getData also, you will get an error. Okay, because this image attribute doesn't exist. Self.image, it is not able to find that, okay, what is self.image, because we have intentionally deleted it. Okay, now I can delete the class also, or delete the functions also. So let us delete the function first. Delete the function or method. That is not called function, it is method. So here I will write delete. I will write, let us delete from the complex number. So see, I am writing complex number dot get data. Okay, I am not directly applying this function on the object. So that's where you would see that here num1 was the object dot the attribute and deleting it. But right now intentionally I am just deleting it from the class itself. So let us see. Now if I execute num1 dot get data, get underscore data. Okay, so you would see that now the error is changed. Now it is telling that this complex number has no attribute get data. Okay, there is no get data inside this. There is no get data inside this. Okay, so if you want to delete an object, let's say I want to delete the object, delete num1. Let us delete this. So this is, I have deleted the object, deleted the object. So if I now print num1, so see, num1 is not defined. We have deleted the object. So basically we do not perform these operations, but at least you should know. Okay, at least you should know. Let us create one more class for the candidates who joined late. So let us create one more class. Let us take another example and extend the parrot class. Extend the parrot class. Okay. Now I am going to create a class parrot. Okay, and let us assign a doc string. This is a parrot class. This is a doc string to this class. Let us create the class attribute. So I am telling that, okay, species, this belongs to the bird species. Parrot belongs to the bird species. Now let us try to create the instance attribute. Instance attribute, that is invoking, that is creating the constructors. Instance attribute, that is creating the constructor. So how to define the constructor? Underscore underscore init underscore underscore. First object is self, then okay, it has a name and age. Then here I will define self dot name equals to name, self dot age equals to age. Okay, now I have created this constructor or defined the instance attribute. Let us define the instance method. Okay, so here I'll write define, let's say a parrot would sing. Self is the attribute and what is the song that you want to sing. Very simple. It will just return a formatted string. Okay, in this just return the formatted string self dot name. Okay, the name of the bird, sings which song. Okay, self dot song, what song he is singing. Okay, let us create another method. Let's say dance. So self comma, I can take one more attribute, or let it be, we can just return again a very simple example. I will tell self dot name is dancing. That's it. Basic class which I have created. Okay, which I have created. Let us now instantiate the class. Instantiate the parrot class. Okay, now I'll write blue, let's say parrot class, and I want to invoke it using the name and age. Let us give name as capital Blue, which is the name of the parrot, and age is 10. Okay, so this object is created. Now let us call our methods. Okay, so if you see blue dot and moment I press tab, so you would see we can access age, species, because species is a class attribute. So see, you can directly access species. You can access the age because it is an instance attribute and we have assigned the age to the self.age. You can access name because it is being assigned to the self.name, and all the instance method you can access sing and dance. So let us now call sing. Okay, sing, and let's say let us give the song name as happy. Okay, blue dot. Okay, why it's not taking? Okay, I'm just checking. It is giving out error in here. Okay, so it is giving error in this formatted string. So I just want to see. So I guess it is not able to take this, and let us see. Okay, so I think it is not taking the formatted string here. It is not taking the formatted string here. So that's where what I'll do is I'll just change this format. No worries. Let us change this format. Dot format, and I can write here self dot sing self dot blue. Sorry, name comma self dot. What is the song name? Self dot song, and I'll get the error here also. Let us remove the formatted string. Dot format self dot name. Still, I'm getting an error. It's strange. Did I wrote something wrong? Okay, it is saying blue dot sing. Blue dot sing. Okay, I call this method and I pass the song as happy. Does anyone is able to identify any error? Okay, the problem I got it. I am passing self dot song, which is wrong because I need to pass song. Okay, we need to directly pass song. Okay, so let me correct this. We can write a formatted string also. So let me go back. Okay, so see here we can pass, we need to only pass song because it is not self dot song. Okay, so that's where you would see that blue sings happy. Blue sings happy. Okay, so self dot name is blue. So that's where it is being passing here, sings, and the song what we have passed here. Now let us call another method blue dot dance. It is not taking any parameter. So that's where you would see blue is dancing. Okay. So sing and dance are the two methods, and they are known as the instance method, and they are called on an instance object that is blue. So if you understood the concept of class and objects, let us go to the another concept, which is inheritance. Now going forward, whenever we will move on to the machine learning concepts, I would be discussing on the classes only. Okay. Now what we are doing is in industries, how it is working. They won't write each and every statement in this Jupyter notebook. They would just wrap every logic of the data science or data analyst, any logic that would be encapsulated inside a class. Okay, that would be encapsulated inside a class. Now what is inheritance? Okay, inheritance, it is a way, it is a way of creating a new class, way of creating a new class for using details of an existing class. Okay, so we will without modifying it. So now inheritance, we would use some existing class and we will extend that class. Okay, without modifying the that class. Okay, so it has the concept of, it has two concepts. One is the base class which is known as parent class, and another concept is the child class. Okay, base class and the child class. Okay, child class is also known as derived class. Child class is also known as derived class. Okay, so what is the syntax? Let us first understand the syntax. Syntax. If you understood the concept of classes and objects, then it is pretty easy. So syntax is class. Then what is the class name? So let's say class name is base class. You can give any class name. Okay, and here it would be our body of base class. Okay, then we will write another class, any name. It could be any name. Derived class. Let's say derived class. Okay, and now you would see I'm extending the base class. This is the extension of the base class, means I am inheriting. Okay, so this derived class is inheriting the base class, and here we have the body of the derived class. Body of the derived class. Body of derived class. Okay, so this is a simple syntax. That okay, we'll define a class name, we'll write logic, then we have another class which is class name, and this is inheriting the base class, and then the logic of the derived class. Okay, now what is the use of inheritance? So let us see. Now what I'll do is we will take the same class. Okay, we will take the same class parent and we'll try to use the inheritance concept. Okay, use inheritance concept in the parent class. Okay, using the same class. Okay, so let us create the class parent class. So first we will be creating the parent class. So let's say class is bird. Okay, so let us create the constructor of that class. This is the constructor or instance attributes, whatever you want to call it as. Okay, so this constructor here I am writing self, that's it, nothing, just I am printing a message here that okay, bird is ready, that's it. Okay, now I am defining another name, another method, that who is this. Okay, is it a bird or what? So let us say print bird. Okay, what is the species name? Is it a bird or not? Okay, let us create another basic method, and this method will just print swim faster. This method will just print swim faster. That's it. Okay, so this is a class. It has one constructor and it will print a message bird is ready. There's another class, another method, and the method name is who is this. It will print bird. There is one more method that we have created which is swim, and it will just print the message swim faster. That's it. Okay, the class definition is over. Now I will write another class. Let us write another class. So now the first class is being created. Let us now create a child class. So here I'm creating one more class, and class name is penguin. Okay, and now this penguin is inheriting the attributes of the bird class. So that's where it is a concept of inheritance. Now I will write define underscore underscore init underscore underscore. This is a constructor. So okay. Now important thing and the interview question. Important thing and interview question. Inside this init, I want to access the attributes of the child class, parent class. Okay, from child class, if you want to access the attributes of the parent class, from the child class, if you want to access the attributes of the parent class. So let's say inside this child class, I want to call this constructor. Okay, I want to call this constructor. So how would you call this constructor? So that's where I would use a keyword super. Super. Super is a keyword through which I can access the attributes of the parent class. Super dot and see, let's say if I press tab, uh, super function dot and see the moment I press tab dot and press tab. So see, I can access swim class, swim function. I can access who is this function, and I can also access the constructor. Okay, so let us access the constructor in it. So I am calling the constructor of the parent class. This is a calling the constructor of parent class. Okay, calling the constructor of the parent class. Intentionally I am doing this, and let us print here penguin is ready. Okay, now inside this child class I am again defining who is this self keyword, and we know who is this. So let us print that this is a penguin, right? Penguin. Okay, if you notice here also we have who is this, but here it was bird. Now here who is this is penguin. Let us now create another class which is, let's say, run and self. Now I am printing that run faster. Print run faster. That's it. Okay, now I have created the child class, I have created the base class. Let us try to call. Okay, now since child class is inheriting the base class, so we will create the object of the base class. Let me write it here. Since child class is inheriting the base class, so we would create the object of base class, child class. Okay, so let us create one object as p1 for penguin. So if I create an object of this class penguin, so you would see that okay, I'm getting an error. I'm getting right now error that penguin underscore underscore init. Okay, why it is giving an error? Okay, it is underscore underscore init underscore underscore. Okay, so see, the moment I created the object, so it went to the constructor, it invoked the constructor, and first line it saw that okay, I need to go to the base class and I will invoke the constructor of the base class. So it went to the base class, and that's where it is just printing bird is ready. So that's where you can see that you are getting the output as bird is ready. Then it went to the next statement, and here you are getting penguin is ready. That's where you could see that the output is penguin is ready. Okay, so that's where we have created the object of the child class. Now let us see p1 dot. See, I can access run, okay, which is the function here. I can access swim, which is the function of the base class. So see, base class, who is this? Who is this? Now the question is on who is this. If you notice this function name and this function name is same. This function name is same. Okay. By creating the object of the child class, I am able to access swim. I am able to access run. I am able to access who is this. Now this who is this function is same in both the classes. That's where this function would be overridden. What do we mean by overridden? So let us see the output of who is this. So see, it is giving us penguin only. Okay, that function is overridden. Okay, this function is being overridden with this. Okay, now let's say, let us do p1 dot swim. So if I call swim function, so this is function of base class is overridden and we are able to access child class. Okay, this is invoking method or function of base class. So see, I'm getting swim faster. This we have created in base class. Okay, then let us do p1 dot run. This is the method for invoking method of child class. So by creating the object of the child class, you can access all the attributes and the methods of the base class. You can access all the methods and attributes of the base class. Getting? Okay. Let's say now you say, okay, sir, we also want to access the base class attribute. We also want to call this base class. So inside who is this, you can also create one more thing, super. So let's say if I write super dot and let us see who is this. And now if we see, if I run this, so let us do penguin dot who is this. So see, first it is calling the base class and then it is calling the child class. Okay, super function is used to access the attributes. So explicitly calling the who is this class of base class, who is this function of base class. Okay, this is a concept of inheritance. Let us take one more example. I think this would be last concept for the inheritance, and if in next session we'll get some time, we'll discuss about the polymorphism and abstraction. Okay, there are two more concepts, polymorphism and abstraction. Okay, but let us now one more example of the inheritance. Example 2 for inheritance. Why we are not taking all the concept intentionally? I'm not taking all the concept because it would be very difficult to digest. So three concepts: class, object, and inheritance. So I'll create a parent class, and the problem statement is that we want to calculate the area of the, let's say, polygon and area of the triangle using inheritance. Calculating the area of triangle and polygon. So let us take a very basic example, and here I am creating a class, let's say polygon. This is my base class, and here I'll create a constructor. Let us create a constructor, and here I will give the number of sides. Okay, then I'm assigning this number of sides to the instance of the class. Okay, then I'm defining one more self.sides, creating one variable. Okay, and here I'm initializing all the sides with 0 for I in range of number of sides. Okay, what this step is doing, initializing all the sides with 0. Okay, I have created these two attributes. Then let us create another function, input sides, and in this input sides what will take an input from the user. So this self.sides will take input from the user. Okay, I'll take, so how to take an input from the user? So we can take input by this using the input function, input, enter slides, right? Oh, sorry, side, enter side, and let's say we can do str of I. What I want is to enter side, let's say 0. So if I want enter side is 0. Okay, so I can take a input from user. I can take the input from user. So if I run this, and let's say user enter 2, but this 2 is string. This 2 is string. Okay, the output is string. So that's where I need to convert this to a float. So that's where I will encapsulate this function with float, and let's say enter side 0 is 2.0. Okay, enter side, then I want 1. Let's say triangle is 2 sides. So let's say I'm entering 3.5. So see, I'm getting 3.5. Okay. So what I will do is I will take this function. I will take this function and write it here and assign. So I'm writing float input, and we are taking input from user, enter the sides. Okay, plus, and the side should be str of I plus 1. Okay, plus colon. That's it. Now I am writing for I in range of self.n. Okay, so if you are not able to understand this, so let us assume that number of sides n is 3. Number of slides self.n is number of sides is 3. So what I can do is, so I can write for I in range of n, for I in range of n. Okay, and this function is just writing like this, float. Yes, okay. Now if I'll run this, so see it is directly giving enter the side 1, 0 plus 1. Okay, so I have entered 3.5, enter the side 2, let's say 4, enter the side 3, let's say 2. Okay, so see we have taken 3 inputs. Instead of writing like this, I have done this in list comprehension. This is a list comprehension. Okay, instead of writing it in multiple lines, I have created this in a list comprehension. So we have taken the input from the user and we have saved this. Now we will now display the sites. Display sites. Okay, let us display sites, and here we write for I in a range of self.n. Let me write it without list comprehension. Print side, okay, comma I side 1 is self.sides of I. Okay, so we are just printing all the sides. We are just displaying all the sides. So we are doing nothing. In the class polygon, what I have done, I have created a constructor. So we are taking that how many sides you want. Okay, if user has given 3 sides, then initializing all the sides with 0. Then we can take the input of the sides also, and we can display the sides. Okay, now I am creating a child class. Now that class, let's say triangle, and that is inheriting the class polygon. Okay, now if you see here, I'm just invoking the constructor, and I'm just calling the a constructor of the polygon in it. Okay, now if you see this, when I invoke this constructor, it is taking the number of sides. So that's where I need to define that how many number of sides you want. So that's, let's say it is a triangle, so I'm telling that I want 3 sides. Okay, now I will define area. Let us find the area of the triangle. And here I would define, okay, I forgot to define self is mandatory for all. So find area, and here I will define self. Okay, now in this a comma b comma c is equals to self dot sides, which would be coming from here, because we are using the concept of inheritance. So we are assigning a, b and c as 0. Okay, because the moment I invoke this constructor, all the sides would be assigned 0, and that's where A, B, C would have 0 at this point in time. Okay, now let us calculate the semi-perimeter. Let us calculate the semi-perimeter. So formula is S equals to A plus B plus C divided by 2. Okay, A plus B plus C divided by 2. Okay, now let us print the area of triangle. The area of triangle is, okay, and let me write it. Calculate the area. Area is equals to S into, this is normal formula, S minus A into then S minus B into S minus C, and this whole would be in the under square root. So that's where I'll do to the power 0.5. It is square root of S into S minus A into S minus B into S minus C. Okay, since I am not doing np dot square root, so that's where I am doing power of 0.5, and I am just printing the area. So we have created a child class, and let us now try to invoke this. So creating the object of the triangle. So I am creating the object of a triangle. So here I have created an object, creating the object of the child class. Okay, so this child class have already invoked this child class. If you see, this child class have invoked the uh, base constructor. If you see t dot, that's where you would see that now we are able to see n. So see, that is 3. We have passed 3 and it has invoked the base class, and this n is present in the base class. Let us see what is there in sides at this point in time. All the sides, 3 sides would be initialized with 0. See, that's where we have initialized all these 3 sides with 0. You give the number of sides, I will initialize all the sides with 0. Okay, now we will now invoke the input sides. Now we want to input the sides, right? We haven't inputted the sides, so let us now input the sides. So that's where I'll call t dot input sides, and you could input the sides. So let us input 3, 4 and 5. Okay, so now if I call t dot sides, so that's where you would see now the value is 3.0, 4.0 and 5.0. Why? Because when we call this function input sides, it has replaced that 0 self dot sides where we initialize with 0, 0, 0, that is now being replaced with the user entered input. That is now been replaced with the user entered input. So let us display the sides. So let us d dot display sides. Let us call this function. So see, side 1 is 3.0, side 2 is 4.0, and side 3 the user enter is 5.0. That's where we are just trying to display the sides. So we have displayed all the things. So I have we created the child class object, and using child class object we have accessed all the attributes. Okay, all the attributes of the parent class. Now let us find the area. So the moment I click find area, so self.side has 3.0, 4.0 and 5.0. So 3.0 would be assigned to A, 4.0 would be assigned to B, and 5.0 would be assigned to C. And then you can calculate the perimeter and it will give the area of the triangle. So let us call that t dot find area. The moment I calculate, so see, we got the area of triangle is 6.0. Okay, the area of triangle is 6.0. So S is equals to A plus B plus C by 2. So 5 plus 4 is 9 plus 3 is 12. 12 by 2 is 6. Okay, now 6 into 6 minus 3, that is 3, and then 6 minus 4 is 2, and 6 minus 5 is 1. Okay, so 6 into 6 is 36, and 36 to the power of 0.5 is 6. So that's where you are getting output as 6.0. So guys, I think that's it. We should stop here, and I think you enjoyed today's session and we understood the concept of classes, objects, inheritance, and we have seen the ample of examples for the classes, objects, and inheritance. In next session, we would continue with the concept of the polymorphism and abstraction. So I hope you liked today's session. So the recordings would be again posted over the YouTube channel.